First of all, good evening to all of you. And as you know, and I think I explained in very first chapter or module that what is the difference between discrete and continuous number. And you can clearly understand that discrete are only integers. It can be, not decimal values. So here in this chapter, chapter number 6 is based on discrete probability distribution, and chapter number 7 is based on continuous probability distribution. So we are going to cover both. We are going to learn how do we do in Minitab also this. So let's start with this. First, so the probability of any, the total probability is 1, and the probability of any event is between 0 to 1. So any event probability can be 0, can be 1, or can be in between. Similarly, the sum of all the probability events is 1. This we understand properly. And based on that, let's say we flip, 3 coins together. What are the, possibilities? All 3 head, 1 head, 2 head, 1 tail, 2 head, 1, first could be head, second could be tail, third could be. So all these, possible chances. And this is called sample space. So possible events, let's say, this is if you flip 3 coins, what is the probability of having 0, of having head 0? So here in this, only this event, we will not have 0, we will not have head, and which is 0. In this case, at least 1 head. In this case, at least 2 heads. In this case, all 3 are heads. So these are the, for example, X values. What is the probability here? 1 event where there will be no head. So 1 divided by 8. There are 3 chances, or 3 where you can have 1 head, which is 3 divided by 8. So, and 2 head chances are 3. This is, and all 3 is 1. So this is very simple example. Here, this is the probability distribution of 3 coin flips. We are not using any continuous number. Only you can see what is the probability of 0 head, which is 16.67. And therefore, 16.67, because that is what I started with the class, that 30 out of 180, how much? 16.67. Oh, sorry, 12. This is out of 8, which is 12.2, 12.5. So this is because we have 8, so divided by 8, which is 12.5. Now here, 12 plus 12 plus 12, and that 37.5. This is also 37, and this is 12.5. Put together, this is going to be 100% or 1. So here, you can understand only discrete numbers are there. 0 head, you can't have 1.5 head. You can't have 2.5 head, 2.67 head. You can only have 0 to 3. So this is discrete probability distribution. Now, PDF and CDF. What is the difference between PDF and CDF? So this is a clear example of PDF. The PDF is, meaning is individual event probability, that is probability distribution, and CDF is cumulative distribution function. And I can very simply explain using my, can you see my, I'm just going to share my, can you see my Excel part?
Yes.
Okay. Here, in simple form, let's say we all get salary, let's say this is a salary distribution of about 12 months. You know, salary has some fixed component in each of the salary, and salary has some variable components like some incentive, some bonus, some something. So for example, January to December, this is the salary that we are getting here. And the total salary, how much we get in the year, that we get, you know, we can get to know through form W2. So this is 121,700. So this is the salary. So, and this is a cumulative. Cumulative means first month so far in January you received, by the month of February you received 10,000 plus 10,200, which is 20,000 plus 200, which is third month you received so far this. By the month of August you received 79,400. So let me, so for example, if you can see this chart, if you can see this chart, I'm just using only, you know, some people get weekly, some people get, you know, bi-weekly, but this is for simple understanding, January, February up to December. And this is, you can understand PDF. And now this you can understand as a CDF, that, you know, by the January you received 10,000, by the June you received 59,900, by, you know, December you received 121,700. So this you can understand as a cumulative, which is, this is 100%. Your annual salary, which is 121,000. So this you can say cumulative. Similarly, now I'm going back on my slide part. So I hope you can understand the cumulative part. Similarly, the PDF and CDF, in every distribution, we have these two functions, which is probability distribution function and cumulative distribution function. Now, what is expected value? Expected value is the one which has event and event probability. And that is also demonstrated by mu, and which you can understand what is the meaning of mu. So for example, these are the events. If you have probability distribution of service calls, x equal to 0, 1, 2, 3, 4, 5, these are the possible 6 events. There is a probability of these events, you know, first 0 is 5%, second 1 is 10%, and corresponding. So the total is 1. This probability is total 1. It cannot be more than 1. Expected value is sum of all, you know, so basically multiplying x with probability of x and then summing all, that is called mu, or that is called expected value. So first you can understand these concepts. So I request, if you have any question, you can type in chat box. I request everyone to kindly mute your microphone. Hello there. Okay. Yeah, Kate, I was the 31, you know, so there were 31 people and I was the 31st. So students were 30 only at that time. So this is the, you know, first event, 0 event is 5%, first event is 10%. So its mean is, or mu expected value is 2.75. So this is expected value. And what is variance? Variance is again the same concept. Variance and the standard deviation, as I said, mean and the standard deviations are going to be the most important calculations in our rest of the both the subjects. So variance, this is equation. We don't want to remember any of equation. We just want to interpret these results, interpret these numbers. For every distribution we have mean, for every distribution we have standard deviation or variance. So this is So I'm not going to do this calculation because you understand the meaning of mean and standard deviation. Now very first distribution is uniform distribution. This is likely used, and so for example, I just give to my students, in my class. Let's say I have a basic statistics class of undergraduate students. Let's say I have 60 students in class, and if I say the first year student or fresher, I have 15. Second year or sophomore, I have 15 in my class. Third year or junior, I have 15. And fourth year or senior, I have 15. So what is the distribution based on the seniority, based on the, I have a uniform distribution based on this. So uniform distribution is the one which has uniform distribution. I request you again, let me see who, so that probably I can. I think just please excuse me. Who is the I can't see any mic open. Anyway, so let it be. I hope you are understanding. And so for uniform distribution, the parameters, what are the important parameters? A equal to lower limit, B equal to upper limit. This is PDF function. 1 divided by B minus A plus 1. We are not going into all these equations, these numbers. We are going to see in our mini tab, really. This is the mean, A plus B upon 2, which is mean. Standard deviation formula is B minus A plus 1 square minus 1 divided by 12 and square root. So this is just for your information. In every distribution, we will have PDF, we will have CDF, we will have mean and standard deviation. We have to remember these 4 important things. Means we always get these 4 numbers or 4 options in order to solve any. So for example, this is a rolling a die. If you roll a die, what is the probability of getting 1, 2, 3, 4? All events have equal probability. Means it can be 1 when you roll a die, it can be 6, it can be 3, it can be, from 1 to 6 any. So they have all equal probability, which is 16.67. And that sum up to 1. And so this is a PDF function. And you can see this is a CDF function. CDF is 1 is 16.67 plus 16.67, which is 33.33 plus 67, which is 50 plus 67.67 plus, you can keep 83.33 and 100. So these are the PDF and CDF function, how they look like. The mean for this, the lowest value is 1 and highest is 6. So mean is A plus B upon 2, which is 3.5. Standard deviation is this square root of B minus A plus 1, using all this 1.708 for this particular uniform distribution. Now we come to our business, which is most important, binomial distribution. What is binomial distribution? This is also called Bernoulli distribution, and it is based on 2 outcomes. Let's say I'm going to pass the exam. I have a probability of passing the exam 60%. At the same time, the associated statement is that I have 40% probability of failing the exam. Tomorrow I'm going for car servicing and I have a probability of 80%. Tomorrow I will go for car, exactly the same time I have 20% probability that I will not go for car servicing. So success and failure, they are associated only 2 outcome, yes or no, pass or fail, success or, So this is But whenever you see this kind of situation, this is called Bernoulli or binomial distribution. And here, if pi is success, 1 minus pi is failure. Let's say I'm going to take a Zoom class tomorrow and probability is 10%. So what is the 90%? 1 minus 10% means 90% I am not going to take Zoom class tomorrow. So success is defined as less likely outcome, so that it should be less, it should be pi should be less than 0.5 for convenience. And this is, in some cases, it is used. Probability of 0 plus probability of 1 means, again, this is 0 to 1. The pi value probability of, event can be, success can be 0 to 1. It can be 0, it can be 1. So here expected value equal to pi, Vx equal to pi 1 minus 5. And you can see this is the formula of PDF, and CDF formula is mean is n pi. N means number of occurrence. Pi is again probability. Standard deviation formula is this, and pi 1 minus pi. Look into this at the bottom. Skewed right if pi is less than 50%. Skewed right if pi is more than 50%. Symmetric if pi is 50%. So this is the, we don't want to remember anything out of this, but important again, mean and standard deviation. Now let's look into the examples. So what is the probability that exactly 2 of the next n equal to 12 cars serviced are late, and pi is 10%. So, and car is not late is 90%. So this is, they are just going to do this. We are just going to use our formula. So I hope you can see my mini tab. Can you see my mini tab?
Yes.
Okay.
Yes.
So here under statistics, under calculation, we have all the probability distributions. Binomial probability distribution is right here. When do we need to use PDF? This is probability means PDF function. Cumulative means this is a CDF and this is an inverse. In all the distribution, we have all three options. And those who are using Mac computer, probably they have less functionality as compared to Windows. So I would request you to use the virtual lab in case if you don't find the options. So this is the one thing. You will have all the under this probability, you will have chi-square, normal distribution, app distribution, t distribution, uniform, binomial, geometric, negative binomial, all you can see. Triangular. Here also under graph, you can go under probability and you can go here and you can also see the binomial. Where is this? Is binomial. Number of trials are 12. Event probability is, I think, 10%. Shaded area. What is the X value you are looking for? You are looking exactly, I think 2 it is. If I, let me see the, next, exactly 2. So you are looking exactly 2. Here, left tail, boat tail. So basically it gives you the shaded area, but here it gives you all the events which are associated with probability 1. So this is 0 event. This is a distribution which has been created, but it does not give you, it doesn't give you the individual event. So you can clearly look into this and you just see what is the answer. N equal to 12, probability is 10%, and probability of event X equal to 2 is 23.0128. So for X equal to 2, you can see this is the probability. This is the one. And similarly, I'm going to, so here also you can see in this answer, in this, on this slide, 23.01. Now look into the same thing about statistics, calculate probability distribution, binomial. Now we have to understand which distribution is this binomial. Is it cumulative or is it probability? Because it is asking exactly on one point, like, exactly what is your salary in the month of July. So it is not asking what is your salary more, after July or before July. So let me see. Here the number of trials are 12. Event probability is 10%. Here input columns are, I'm going to give and the input constant is, we have 2. And you can see exactly 23% is the answer right here. Now one more question is here. For example, I just put the event X, and here I put the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or whatever. And here probability, event probability. So I just put like this, event probability in binomial with 10%. So I just go the same thing, calculate probability distribution under binomial. Yeah, there are questions. Oh, okay. So Joel, the question is right here. I can show you. This is can you see this?
Yeah, but that data looks like it's from the car problem.
This is just an example. This data can be based on the based on the database, that what is the probability that car is late. For example, Balbolin oil change shop, and everyone puts the appointment before going, suppose, and based on that, they did the data analysis that they booked almost 200 car oil change, and they find 10%.
So you're using, sorry to interrupt, you're using the 10% from the car oil change problem for the salary problem.
Oh, I'm just using this example. Can you see my screen?
Yes.
So I'm using exactly 10%. I'm exactly using the same problem to put on Minitab and solve it.
Okay.
Is it confusing or something? I'm not making it clear.
I think we're still trying to figure it out.
No, this is exactly same. You just look here. What is the probability that exactly 2 of the next 12 cars serviced are late? So X equal to 2, N equal to 12. And the probability of the car is late is 10%, which is given here. And I'm not doing any extraordinary things. I'm not solving this. This is the answer right here. How we can do using different ways in Minitab, that is what I'm demonstrating.
Okay, got it.
So, yeah, okay. So for example, this is input column, and we got this value, using exactly same, and we got this value. Now, for example, we would like to see here, we would like to see 2 cars. Now I'm interested in 3 cars. I'm interested in 4 cars, 5 cars, so on. How I can do one? And that is called entire probability distribution. So I go under calculation, probability distribution, and I can go binomial. Instead of this, I can use the input column. Whereas I put all the events under input column, which is 6. Output storage, where I can put my output in EP, which is, and now you can see this is the probability of event 0, event 1. So for event number 2, exactly, I can't highlight here, but you can see the 23.01. I mean 0.2301. Exactly the same answer. So this is entire. For event 3, this is. For event 4 is this. Event 5 is this. Event 6 is, I mean, how 7 cars will be late, 8. Now same thing I'm going to demonstrate to you using third pattern, which we used to do when I did not have the computer, and I used to have only these tables. Can you see this?
Yes.
So look into this. This is n here, x is here, and this is 10%. Sorry, 1%. This is 2%, 5%. This is 10% column. And this is n. So look, we are going to, so basically 1, 2, 3, 4. So we are going to look n equal to 12. And n equal to 12, and this is the column. 12, and this is the column. So basically exactly the same values we got using Minitab. And what we are interested in, this is 23 points, I mean, this number. So you can also use the table if you have problem for exact numbers. So I demonstrated the same problem using 3 different ways. So this is the interpretation of table. And here you can see exactly for 2 number, I mean x equal to 2, where n equal to 12 and pi is 10%. And this is there at the end of every book. I mean, these tables you can also observe, at the end of the book. Now I'm coming back on slides part. So this is simple. Now look into the second example, which is on an average, 20% of emergency room patient at hospital lack health insurance. So this is the general data that came from the patient that, hospital normally stored that, whatever patient they come to hospital, out of that 20% are uninsured. And they would like to say, see in a random sample of 4 patients, what is the probability at least 2 will be uninsured. So here pi is given, which is 20%. So at least 2 will be uninsured. So n equal to 4. The range of patient equal to x equal to 0 will be uninsured, 1 will be uninsured, 2 will be uninsured, 3 will be uninsured, 4 will be. At least 2 will be uninsured. Now this question is, this wording you can understand, this is not simple PDF. It is asking at least 2, means this has 0 event, 1 event. So these at least 2, 3, 4. I'm going to explain this because this here we get confused always when you have this kind of situation. So it is asking, it is compound event probability. It is asking at least 2, means 2, 3, 4. So if you do the probability of 2, probability of 3, and probability of 4, this is going to sum up to 18%. But this is multiple step process. You have to do 3 times, and 4th time you have to sum this. How it can be done it quickly? Using CDF function. So very simple. So I'm just going to do. So I go here under calculate again, probability distribution, binomial. And now number of trials are 4 patients, event probability is 20%. And now instead of that, this is cumulative function. Input is asking at least 2. Then what I need to do, I need to put 1. Why? I'm going to explain. And whatever value we got, we have to subtract from 1. Whatever value we get 81.92%. We have to subtract from 100 and we get the answer, which is 18%. Why am I doing? The answer is here. I'm just going back on my Excel sheet. And please focus here, because this is the most critical part, that we normally make mistakes when we putting the X value. So for example, this is our salary in cumulative form. And my question here, what is the salary? I have both the graphs here, I think I can not put side by side, but you can see, understand. What is the salary, how much you earned after July? My question is, how much you earned after July, or what was your salary after July? What you will say? Then you have to go, you have to do August, September, October, November, and December. You have to take all these 5 salaries and you have to sum, and then only you can get. Otherwise, in PDF form. In CDF form, what you can do, your annual salary is 121,700. Okay. So what I can do, I can get the salary up to July, which is 68,900, and I can subtract from 121,700 and I can get the answer. So my total, which is 1, I can say 1, and I can go up to July and I can get this 68,900 and I can get the answer. Instead of doing multiple steps in this, if I ask the same question, what is my salary up to June? So I don't need to do January, February, March, April up to June. I can go and I can just do the June in CDF and I can get, okay, this is my salary up to June. Similarly, if somebody asks, what is your salary between May and July? So I can go up to July, I can go up to May, and I can subtract July, May from July, and I can get the value. Are you getting me what I'm trying to explain? Similarly, in this CDF, the total CDF is 1, and it is asking what is the at least 2, means if I can get up to 1, so it is, if you look into the question, either you have to do probability of 2, 3, 4, or you can get up to 1 and subtract from total probability, which is 100%, or return is 1, and you can get this number. This is compound event probability. So look into, I'm just going to demonstrate one more time here. And if you don't understand, just ask me. So I'm going to do here, calculate probability distribution, and binomial right here. We are still on binomial. Number of tries 4, event probability, input constant is just 1, because we would like to get more than 1, because it is at least 2 and more than. So the cumulative again, so we got 81 point, and then we are going to subtract this from 100 or from 1. We are going to get the event probability, which is 18.08 or 0.1808 as the answer. Is it making sense?
Yes.
Okay. Yes, if they said at least 3, would that exactly, then we are going to at least 3, means they are not counting 2, 3, 4, 5. So what we are going to do, calculate probability distribution calculate probability distribution binomial, and here instead of 1, what we are going to do here, 2, and the up to 2 is 97.2 0.9728. Subtract from 1, so at least 2, which is going to be almost close to 2.6 something, 0.026 something. That would be the answer. Okay.
Can you
So,
explain again why you change when you know how to change the input constant?
yeah, this is, you don't need to, for 0, PDF and CDF, they are always same. So for 0, Steve, yes, they are the same. Even you use CDF or PDF. Yeah, so why am I changing the input constant? Because I think, there was a question in the chat box, therefore I was changing. Did I answer your question?
Yes, thank you.
You're welcome. Yeah, there was a question that if they said at least 3, would the same process work for 2? Yeah, so I just explained. Now, what is the probability that fewer than 2 patients have insurance? So the question, you can understand what it is asking, fewer than 2. That means it is not asking 2. What is fewer than 2 is 1. So it is asking 0 and 1. Remember, this is discrete event probability. So fewer than 2, which is the earlier event of 2, is 1, 0, 1. If it is asking more than 2, means it is not asking 2. You have to put 3. So fewer than probability of 0 and 1. So what you are going to do, when it is always less than event, it is asking less than something, you don't need to subtract with 1. When it is asking more than question, you have to subtract with 1. So because you can clearly see, if I ask what is the salary till May, it is right here on, when you do put May, it is 51,100 clearly coming here. When it is asking more than, after May, then you do up to May, then subtract from 121. So always remember this concept. So in fewer than this, I'm just going to show the same example. Calculate probability distribution, binomial distribution, and I just put input constant 1. It includes 0, it includes 1, and right here 81.92, and the answer is right there. So now, what is the probability that no more than 2% have insurance? Means it is asking up to 2. So just put x equal to 2. It is not asking no more than 2, means up to 2. So these wordings are important. What is the mean of this? N pi, which is 4 multiplied by 0.2, which is 0.8. Standard deviation is also 0.8. So this slide is most important. If you understand this slide, I think, like 25% of problems are solved. At least 2 means it includes 2, means this you have to, if it is asked at least 2, means you are going to put x value 1 and subtracting from 1. Fewer than 2 means you are going to, again in this case, you are going to put x value 1, because fewer than 2 is 1, and you are not going to subtract. Fewer than 2 or more than 2, so again more than 2, fewer than 2, again you are going to do this thing. More than 2 means you are going to, in more than 2, your x value will be up to this, and then you are going to subtract with 1. So if you understand this, because if it is asked, normally people what they do, if fewer than 2, they just put 2. More than 2, they just put 2. We have to think it critically, what is the X value? If that makes sense, and if this is clear, I think our, major problem is solved. Should I move on?
Yes.
Okay, thank you. Now, if you understand the binomial distribution, now the next is Poisson. The way you pronounce in my country, we learn, Poisson distribution. So please don't go by my, pronunciation, because it's different from you. This distribution describes the number of occurrences within a randomly chosen unit of time. Let's say if you work in a restaurant, or if you have a big store, how many customer visit per hour, per minute, per second, or how many flights arrive in airport, how many flights depart. So this is basically based on chosen unit of time. So we call it time continuum. So this is the, if you have this kind of situation, use Poisson distribution. And the most important thing here is lambda. So where lambda represent the mean number of events per unit of time or space. So if you have a question, you can go for Poisson distribution. So here pi is mean arrivals. So mean is, this is PDF, mean is lambda, and square root of lambda is standard deviation. Making sense? Now, if you remember these things, now, for example, this is the question: on particular morning between 9 a.m. to 10 a.m., customer arrive and enter queue at University Credit Union at a rate of 1.7 customer per minute using Poisson formula, PDF, mean, and standard deviation. So this is a PDF. You can do, how I can do the PDF? Very simple. Again, I'm going to do here. So I'm just putting here, if you can see my PDF. Now I go under calculate, I go under probability distribution, I go Poisson distribution. Where is Poisson? Right here. And probability distribution, what is this thing? 1.7 input column. I'm again taking X values, all the X values, and I'm using where I'm going to use this, store it in PDF. So let me remove this. This is a PDF of, it can go further if I have, other values. So this is a PDF of event 0, 1, 2, 3, 4, 9. This is the thing. And I can do exactly the same thing here under graph probability distribution. Okay. I go under this, I have Poisson right here. Lambda is 1.7. Shaded area, I'm not going to put any. So let me remove this also. Okay. I have to do, for example, it's just something, So if you, so you can see what is the value, 18.26% for event 0, that you can clearly see. Probability of event 1 is 31%, which is, you can clearly see. Probability of this 26, which you can clearly see, and so on and so forth. So this is PDF of, you have to give some values. So I put 2. So, all the values after 2, 2 and 2 after 2 are red. So this is a PDF of this. Now I'm going to demonstrate the same thing here. Can you see my screen on of appendix of distributions, Poisson distribution?
Yep.
Yeah.
So it is based on lambda. Lambda value is whatever, you can say. So this is the value that we selected. And based on this, these are the numbers. We exactly same numbers we got in our. Think about where it ends. You know, if you have, for example, lambda up to 20, this tables, this works well. If you have more than 20, then every distribution follows normal distribution. Similarly, I wanted to show you this also option. Where is this? Binomial probability distribution, up to what n this will work? When you have n equal to 16, then this works. You know, if you have n is larger than that, you know, they come close to normal distribution. So if you have a small n sample 16, 15, 14, you can use this. But if you have more than 16, we are going to cover in chapter 7. Okay, so what is the mean? Mean is exactly 1.7 because lambda is 1.7. What is the standard? Square root of lambda, which is 1.304. So this is, again, in this case, the question has been asked, what is the probability that 2 or fewer customer will arrive in given minute? Now question has been asked, 2 or fewer. So basically the X value will be 2. And if you want to do individually, you have to do this, 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 and then what I can do, I can simply do cumulative one with 1.7 X equal to 2, and I can get my answer. So probability distribution, Poisson distribution right here. I put here and I put equal to, I put here cumulative because again, this is not asking. If it is asking exact event probability, then we are going to use this probability function. What is the probability of 2 will not come? What is the probability of 3 will not come, or whatever, you know, exact event probability, then we are going to use probability. If it is asking less than, more than, we are going to use cumulative one. Look into this. So this is the answer that we got, 75%, or, you know, 75. And look into the answer. Answer is 75, exact same answer. What is the probability? At least 3 customer will be, 3 customer will arrive. At least 3 means 3 and more than 3. What we are going to do? We are going to put X equal to 2 and we are going to subtract with 1. So already we calculated up to 2, which and subtracted with 1, which is 24%, 24.27. So this is a Poisson distribution. The Poisson distribution may be used to approximate binomial distribution. Now here is the question. You know, this slide becomes important because 1 or 2 questions in homework or quiz is based on this, because when Poisson distribution can be used as a replacement of binomial by setting lambda equal to n pi when the binomial calculation is difficult. So the general rule for good approximation, n should be large and should be small, a common rule. So a common rule of thumb says approximation is adequate when n equal to 20, greater than 20 or 20, because you can see the table is there up to 16 and pi is less than, pi is greater than 5%. So this is important to know, you know, keep in mind while solving the problems. And you can easily convert lambda, you know, n, you know, pi, multiply, you can get lambda, and the rest is automatically done. So this is critical thinking. Now there's another distribution which is called hypergeometric distribution. What is it? The hypergeometric distribution has, you know, population size, finite population. So this is like a binomial. Binomial doesn't have population, but it has finite population. So maybe, so this is, look into the formula. Here is the PDF function, here is the mean function, here is the standard deviation, and look into n equal to number of items in the population, n equal to sample size as is equal to number of success in population. So based on that, we calculate this. Means here, what extra thing you get? You get the, out of, like say, for example, out of 5,000 students, I'm selecting 50 students. So the 5,000 is a population. You are taking a sample of 50 students. So same thing here, the comment similar to binomial, but sampling is without replacement from a finite population. It can be approximated by binomial with pi equal to s divided by n. N upon n is less than 5%. Remember, when this, if sample divided by population is less than 5%, and is symmetric if s upon n equal to 50%. So this condition, however, only 1 or 2 questions are there, but they are straightforward in the assignment. Look into this one simple example. In a shipment of 10 iPods, 2 were damaged and 8 are good. Okay, so the receiving department at Best Buy tests the sample of 3 iPods at random to see if they are defective. Let the random sample, random variable x be the number of damaged iPod for the sample. So this is n equal to 10, small n. They took 3, sample, and this is s number of damage or success in population. So look into the question. This is not a binomial problem because pi is not constant here. And then look into this case. So I'm just going to do mini tab for this graph, probability distribution, view probability. I go under hypergeometric. Population size is how much? 10, I think. Event count in population, there are 2 events, means 2 defected in 10. How many you are going to take? Sample size 3, and I'm not going to do anything. This is the hypergeometric distribution, n equal to 10. And now here, if question is asked, so so this is not binomial problem because pi is not here. You can do different when probability of x in the same situation 0, 1, 2. What is the answer? So calculate probability of distribution. Hypergeometric is right here. Population size is 10, and I'm just going to use this. And event count in population 2, sample size is 3, and input constant, let's say I'm just putting 2 here, and which is coming 6.6%, which is right here. And we also get like 6% right here. So which is right here, what is the event probability of individual? So this is the, so hypergeometric. After hypergeometric, the 4th distribution is geometric distribution. This distribution has unique thing. Look into the geometric distribution, describe the number of Bernoulli trial until the first success has been achieved. Please understand the properties, unique properties of each distribution when they are applied. So this is the PDF, CDF, mean, deviation, all at university, 15% of alumni make a donation or pledge during the annual telefund. What is the probability that first donation will occur on 7th call? Okay. So here, you know, this is like a binomial. 15% of alumni make it, but 85 don't make it. So this is like binomial. But you know, what is the probability that it will come on 7th call or 7th person? So I just see this. I go here and we have is the calculation probability distribution. Where is the geometric? Right here. Event probability. So again, it is asking exactly 7. That means for, so 1 point, what is the 15%? Okay. Input constant is how much? 7th. At 7th call. What is the probability? 5.6, yeah, 0.0565. And that we can see where we are. This is exactly same answer. So this is 5 point. So here they also calculated the mu, which is expected value, and sigma, which is right here. So similarly, what is the probability that it will come within first 5 calls, or, you know, so you can play with, you know, geometric distribution. And this is not important, you know, that we have not no, you know, calculation based on this. If this is clear to all of you, this is number chapter number 6. I can move on chapter 7. It will take another 40-45 minutes. Is it good? This is recording, so, you know, I'm going to place everything, you know, after this on online, so you can see this.
Sounds good.
Okay. Yeah, I need your confirmation or your consent before moving. If you have any question, you can ask me right now. Okay, now continuous probability distribution. If you remember that continuous probability distribution and discrete has 0, 1, 2, 3. Here continuous means any possible value of event can be there. If you remember the difference between discrete, same thing is going to happen here. So most important difference in discrete distribution function, you have the probability of one particular event. Here on one particular point, the probability is 0. Unlike discrete distribution, the probability of any single point is 0 in continuous probability distribution. Therefore, I made 2 MCQs and 2 fill in the blanks so that you can be very clear what is the, otherwise, you know, people normally mess in discrete and continuous and they put wrong. So I keep them separate. The entire area of the is 1, which we know. And mean is the balance point of distribution, which is center point is right here, the arrow which you can see. So, and the cumulative look like this, you know, cumulative goes from, you know, 0 to 1 like this. So mean is exactly, variance is like that, you know, I'm not going to explain again now. Here we have uniform distribution, and uniform distribution, continuous uniform distribution, 1 or 2 questions are certainly there in the MCQ, and that very simple. Here, this is a PDF function. If you look, this is a CDF function. Mean is A plus B by 2, standard deviation square root B minus A square divided by 12. So this is a standard deviation, and this is, you know, look into this. So an oral surgeon injects, many people are left, only 28 are remaining, are, you know, they are in the class. An oral surgeon injects a painkiller prior to extracting a tooth. Given the bearing characteristics of patient and dentist view the time x for anesthesia effectiveness as a uniform random variable that takes between 15 minutes and 30 minutes. So lower limit is 15, upper limit is 30. So A, what is the mean? 15 plus 30 divided by 2, which is 22.5. Standard deviation B minus A divided by 12 and B minus A square divided by 12. 30 minus 15, which is, if we can simply compute, these are the, and similarly you can do the event probability. So I think the question in this is related to only, we need to find what is the value of x between 20 and 25 based on this. Okay, so if I go, Mariana, about 12, I have to, this is the calculation, I have to derive the formula and then I have to explain this. So that, this y is divided 12, how it is coming, this will be like, pure mathematics and pure statistics class where I can demonstrate this 12. So just, do you want me, I can give you separately. You want me to continue here, I can do that.
No, that's okay. You can move on. Thank you.
Yeah, because many of the things which are right here, they are based on the, more, basic, we have to assume something. For example, sigma is r upon 6. How 6 is given, we have to look everything. So look into this. What is the probability between 20 to 25? In continuous probability distribution, we see the area, we don't see the particular point. In previous chapter, we see the particular point and beyond. Here we see the area. So look into this. And find the probability that effectiveness anesthetic takes between 20 to 25 minutes. We need to find, so this is mu and this is standard deviation. This is A and B. So I'm just going to use graph probability distribution. And here again, I go under uniform. Where's a uniform? At the bottom, right here. Lower point, we have, what is the lower point? 15 and 30. So these are the, what area we need? The area we need for this is 20 and 25. Okay. So I need 2, which is 20 and 25. Okay, we are done. So in continuous, what is the probability of event area between 20 and 25 in this distribution? 33.33%. And that is what is, oh, I think, let me close this. So exactly the same thing is right here. Now, after this, a very important thing that works everywhere in our life is normal distribution. It was given by, it is also called it Gaussian. It is also called bell-shaped curve. It was given by German mathematician Carl Gauss. So it has different Gauss distribution, normal distribution, bell-shaped curve. So you can name, different. Most important thing about this, it ranges from minus infinite to plus infinite. Two important characteristics, which is mu is mean, sigma is standard deviation, and 99.73% limit is between 3 sigma minus and 3 sigma plus, that we have already seen. And you can see, this is the normal distribution PDF. This is domain is minus to plus infinity. Mean is this, standard deviation is this, and you can see this. The most important thing which I would like to explain here, these 2 points, if you look into these 2 points, they are not zero. They touch, they are very, 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 very close to this line, very, very close to zero, but they never touch in this normal distribution. Therefore, the limit is minus infinite to plus infinite always, remember. So this is minus 3 sigma, this is here plus 3 sigma. Mu is mean and sigma is standard deviation. So mu, mean plus 1 deviation, mu plus 2 deviation, mu plus 3 deviation, similarly mu minus. So mean is center point in normal distribution. CDF is like this, it is start from here, it goes up to 1, close to 1. Y is normal, so these are the some of the things. Most important thing, possess a clear center. It is measured on continuous scale, have only one peak, exhibit tapering tails, means they don't touch, and be symmetric about means. To be regarded as a candidate for normality, a random variable should be. So these are the characteristics we must understand. So what is when a range is large, we often treat discrete variable as a continuous variable. Like, binomial, if you have binomial n equal to more than 16, 20 plus, we treat binomial distribution as a normal distribution. So this is the formula of normal distribution. Z equal to X means individual value, mu is a, what is the clear center on the CDF? We don't have, CDF is cumulative, in this is the normal PDF. CDF will not have the center, it is, cumulative. And I was just talking about the normal, why it is normal. CDF doesn't have. So yeah, X means individual, mu minus mu and sigma. So this is, and so after normal distribution, we have a standard normal distribution. What is the difference between a standard normal distribution? Mu is always 0 and sigma is always 1. Mu is always 0, sigma is always 1. So mean is always 0, sigma is always 1, and this is the formula of PDF. Domain is minus to plus infinite. And so for example, this is 0 is mean, minus 2, minus 3, plus 1, plus 2. This is standard normal distribution. And this is again CDF. And now under this, we normally calculate the area. So we are going to see the area. So just, this is most interesting. I'm just going to do graph probability distribution and look into this. Here I'm going to do normal. Where is a normal? Normal right here. Mean is all in normal, this is normal standard deviation, because mean is 0, standard deviation. When it comes, if you are doing, they are always 0 and 1. Shaded area, suppose I need this area between, this particular 2 points. So I would like to see like plus 2 sigma and minus 2 sigma. Also minus 2, where I can put minus 2 to plus 2. Here you can see, and as we remember, minus or plus 2 sigma, the 95.45% is there. Similarly, I can do so 0 is the mean, minus 2 to plus 2. Similarly, I do for probability distribution, and here I can see this minus 3 to plus 3, and that will be 99.73. And you can see 99.73 between minus to plus. So this is a standard normal distribution. Suppose we are doing this for any real number. Suppose, let's say about the score of the class, score of performance, and I have the numbers. What is the mean? What is the standard deviation? So let's say probability distribution. I'm just going to take, dummy number. The mean of the score of my statistics class is 92. This standard deviation is 7. Now I would like to see in what percent of standard, if suppose I scored 88 points, in what percentile I am in. Okay, so I just do left tail and my value is 88. So basically you can simply understand 92 is mean. That means this is 50% of the curve. So I'm certainly below, which is 28%. So suppose I go again with another example. Let's say my average of my class is 72 with 5 is a standard deviation and I score 88. Where I am standing? Oh, it is 99.33%. So similarly, I just do for one more example here, which is, let me do it like 879. So 72 is a mean, standard deviation is 5, and I score 79. My percentile is 91.92, which is, I can say approximately 92 percentile. So you can see different, this is again table. I'm not demonstrating because you can see yourself. What is the area? I already said 95 percentile will be minus 1.962 plus 1.96. That I can demonstrate you. So I go under graph, probability distribution, and I just choose 0 and 1 shaded area, and I would like to see minus 1.96 to 1.96. And you can clearly see this is coming 95%. Okay. So similarly, minus 1 sigma to plus 1 sigma is 68.26%. 2 sigma to 2 sigma is 95.44%, and 3 sigma to 3 sigma is 99.73%. So these are the 3 sigma, 2 sigma, 1 sigma empirical rule. So this is, what about, what is the value below 1.96 value? This area is, so you can see any curve, any graph, any area using the values of X, and you can inverse also. So what is the curve value up to 1.966 from minus infinity to 1.966, which is 97.5. What is the value of minus infinity to minus 1.96, which is 2.5%. What is the value between minus 1.96 to plus 1. This. So since we have calculated this, we are not going to use. Now this is the example that I already demonstrated. The class mean is 75 with a standard, suppose John took economic exam and scored 86 marks. There is 75 class mean and standard deviation 7. What percentile John in? So 75 and 7. So let's do this. Graph probability distribution and this, okay, 75 and 7 is the 75 mean, 7 is this. Shaded area is just, we would like to see 88. So I just put here 88, and you can see where John is coming. 96 point, which is almost, you can say, 97 percentile. So, oh, I did something wrong. Oh, 86. I think 88. So I think I did 88. So I have to do it again. So let me put this 86, which is 94 point. So John's score is in 94.2 percentile. So mostly you do GMAT or different competitive exam, you get. So here 92, 94 or 94 percentile he is in. So similarly, you can do different combination, permutation and combination. Inverse value. Now look into the inversely the same calculation. Let's say I would like, the same exam, I would like to say where is the cutoff of 90 percentile. 90 percentile cutoff, where 75 is the mean and 7 is the standard deviation. So I'm just going exactly the same thing here. This remains same. I would like to know where is the 90 percentile. So I go under probability. I use this and I use 0.9. So you can see, so what you can get in inverse, you get the X value. So those who scored 83.97, they are into 90 percentile. This is the 90 percentile. Suppose I would like to know where is the 40% cutoff. Certainly it would be lower than, because 75 is the 50% or middle. I just go at the back. So I just go and let's see where I am. So instead of that, I just put 40 here and just see 50% and 75 and 40% is those who scored 73.2, they come under 40%. So you can easily assume whatever mean is there, which side of the curve it is coming. If more than mean, it is coming on the right side. If less than mean, it is coming on the left side of the curve. So this is inverse basically. You don't need to do this because all the things are coming inverse normal. So basically this is the same thing that you can do using what you are going to get here. You are going to get the X value. Now a very important thing, binomial distribution, and some questions are based on this. So please do your calculation, wherever you see this is the case. Some question, 2, 3, 4 questions are there, 2, 3 questions or 4 questions are there based on approximation. Means binomial distribution can be converted as a normal distribution provided there are conditions. Look into this. So how you can convert normal binomial? These two conditions must be fulfilled. N and pi must be greater than 10. And n 1 minus pi must be greater than 10. 10 or greater than 10. Then you can use binomial distribution as a normal distribution. How you can convert? What we need in binomial distribution? We need pi and n. If you see, if you can, multiply, if they are coming more than 10, okay. Then, for normal distribution, what you need mu and you need sigma. How you can calculate based on n and pi? So n and pi is your average or mean or expected or mu, and sigma is n pi 1 minus pi. This is a sigma. Look into this case, n equal to 32 times and pi equal to 50. So let me do 32 multiplied by 0.5. How much it is coming? 16, which is greater than equal to 10, correct? Now let me look into the second situation, n pi 1 minus pi. So, which is n, which is 32. 1 minus pi means 16. So 1 minus, 0.5. So again, this is coming 16, which is greater than. So both the conditions are fulfilled. Now we can use this as a normal approximation. So here these are coming 16, 16. Find the probability of more than 17 heads in 32 flips of fair coin. So more than 17. Now here one more thing that we have to look into that, because this is a binomial. Now we are treating as a continuous. We have to treat on continuous scale. 16, 17, 18, these are all discrete. What do we do here? So for example, it is asking more than 17. Then what we need to do? We have to take the average of between, what is the between of 16, 17 and 18. So basically, if you look into the previous case in discrete, more than 17 means it is asking 18, 19, 20. It is not asking 17. So basically, in this case, the center point of 17 and 18 is considered. So look into this. So basically, this x is equal to greater than 17.5. So since the cutoff point of more than 70 is halfway between 17 and 18, so this has to be also remembered, that when we convert discrete into continuous binomial, this is the case we use. This is the point that we follow. So this is, and rest, now mean is right here. Whereas n pi is mean, and standard deviation you can create and you can do this calculation. So this is 16, standard deviation is 2 point, and z equal to 17.5, and you can do which is this value. So this can be quickly done. You know the 17.5 value which you are going to do, and you can get this area. Simple, just have to. Now, similarly, normal approximation to Poisson can be also converted into normal distribution. Here, when lambda is large enough, what is the value of lambda that we have seen in the table? I think up to 20. If you have lambda value large enough, that follows also normal distribution. Every distribution follow normal distribution if that is sample is large enough. This is must condition. Look into the example. On a Wednesday between 10 a.m. and noon, customer billing inquiries arrive at mean rate of 42. So lambda is 42 per hour at consumer energy. What is the probability of receiving more than 15 calls an hour? So average is 42, and sigma we can calculate. What is the sigma value? Square root of lambda. So 42 square root of lambda this. Now rest you can do 50.5. Again, this is asking 50. So 50.5, because it is asking more than that. What is the more than 50 means it is asking 51 and so on. So 50 and 51 is 50.5. So exactly the same way of doing this. And this is the probability we can calculate. So this is a normal approximation of Poisson. Now here we have the exponential distribution. And we have 1 or 2 questions in the assignment also. In geometric distribution, we followed, binomial distribution and until first success. Here, if event per unit times follow Poisson distribution, the time until the next event follows the exponential distribution. So this is the important one, and it also has the same thing which you can do here. For example, between 2 p.m. to 4 p.m. on Wednesday, patient insurance inquiries arrive at 2.2 calls per minute. Oh, what are the keywords? So the conditions, for example, Kate, when sample is large enough. So here in that you can understand, for example, here I can show you just 2 things. look into this. Can you see the binomial table?
Yes.
This you can see where it ends. It, you know, whenever you see any book, it doesn't have after 16. It doesn't have any table of binomial which n equal to more than 16. If you have n more than 16 or higher, you follow this. And the second condition, n pi is greater than 10 and n 1 minus pi must be greater than equal to 10, then only. So these are the conditions. Same thing, look into the Poisson. Here is the Poisson distribution. Where this ends, 20. If you have any lambda more than 20, what you are going to do? Because, you know, this Minitab and these things, I mean, when I studied, I had only these tables. What I could do, you know, with this. Because I did not have the answer calculating all the things. So converting this into the, if it is more than that, converting into the normal and doing this. Is it making sense? And the conditions are given over there properly. So the norm to Poisson distribution work best when lambda is large. Can you see this? When lambda exceed the values in appendix B, which I just shared appendix of table. Is it making sense? So it is clearly, if you read those, you know, slides, you will be better off, you know. Yeah, so yeah, I was just going through this example. On Wednesday between 10 a.m. and noon, customer willing 42, and this is, you know, again, so based on this, they have calculated mu and sigma, and then using this. So, and then rest is exactly what we need in normal, mean and standard deviation, and you can do all the calculation. Exponential distribution. So you have to identify which is the exponential distribution. So until first, it is clearly given in this case, event per unit time follow Poisson. Until next event follows the exponential distribution. Again, mu, standard deviation, mean is also here same, standard deviation is also same. Anyway, this is the between 2 to 4 p.m. patient insurance at mean rate 2.2 calls per minute. This is characteristics, or this is a lambda. What is the probability of waiting more than 30 seconds, that is half minute, for the next call? So first of all, you know, if you have a question, you have to convert both the things into the same unit. For example, here is the second, here is the minute. So both has to be converted. So lambda is 2 minutes, x equal to this. So look into this. I'm just going to demonstrate this. Status, probability distribution and exponential. What is the value? 2.2 and 0.5. Oh, just a minute. I think I just, so, oh, this is greater than 50, which is 32%. So probability distribution and exponential. Just a minute. Just More than 30 seconds. So why this is not coming? Calculate probability distribution, exponential again, and cumulative mean is threshold this, which is correct. .5 minute. Hmm. 20. So this is less than equal to 20%. Just give me a little, I will make a video about this, something, my energy, keep talking. So I'm just missing something in order to calculate this exponential distribution. So if we do this here two things are there, left tail, right tail test. Probability of betting more than time is this, probability of betting less than time is this. So here, and after this, the last thing is about triangular distribution. So this is a triangular distribution. PDF and CDF is right here. Domain is, mean is A plus B plus C divided square root of standard deviation, square root of A square B square plus C square minus AB minus AC divided by 18. And this is the shape of triangular distribution. And one or two questions are given, and they can be done very quickly. So what we need to do in triangular distribution, just I show you here in a graph and probability distribution. Okay, I go under triangular. Let's say minimum value is 20, mode is 30, maximum is 61. What is the value after, X value is after 35 and more than 35, what is the probability? So, or in between 35 to 45. So I just put here 35 to 45. Am I correct? Yes. So this is, for example, triangular distribution where minimum value is 20, 30 is the peak, and 61. What is the probability between 35? This is the answer. So this is also their graph probability distribution. Let me do this way here. Where is the exponential? Scale is 1, 2.2. Shaded area is 0.5. Maybe I'm missing something that I will make a video, a small video, and I will upload by tomorrow. So this is just only exponential, which is not coming in this case. So rest, I think I covered everything of chapter 7 and 8, 6 and 7 right here. So if you have any question related to these two chapters except exponential, let me know. Any question? If no, we have 23 people. Thank you so much, and bye-bye. Have a good night. And sorry, some of the emails I could not reply because we have outage in Eastern Washington University, in Spokane and Cheney, this area, because of heavy wind. Yeah, that I'm going to explain to you. So we are having a problem, and therefore I could not reply any email. And Thank you so much. Yeah, so
Thank you.
you're welcome. Bye-bye. Good night. Bye. Good night. Okay, so this you ask, that is the threshold condition we have to explain. I'm going to make a video and going to upload to you. Thank you. So you will get the complete information in the exponential one.